Good morning, dear students. My name is Ferhan Mazher, and today is 22nd December 2021. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. And this is Cambridge O Levels Physics 5054. Today, we have selected an alternative to practical, we call it paper 4. We have selected May June 2018 4-1 paper. This paper 4 belongs from the zone 1, or we call it the variant 1. So this paper, the time allowed for this paper is 1 hour. So let's start this paper. Okay. So the question paper will show up on your screen. So the first May June 2018 4-1 paper. A student has two metal rods. One rod is made of copper and the other is made of iron. She carries out an experiment to see which metal is the better conductor. She lays the rods across a heat-proof mat placed on a tripod stand with the rods touching at one end as shown in the figure 1.1. So these are the two metal rods. This one is the copper rod. This one is the iron rod. They are touching each other here. They are on a Bunsen burner. Here on this side, we have put some wax and a drawing pin on in the wax. This is the tripod stand. She fixes a drawing pin to the other end of the each rod using a small amount of wax, which has a low melting point. She then heats the rods at the touching ends as shown. So hopefully you can see this whole thing. State two features of the apparatus shown in the figure 1.1 that ensures that the experiment is fair. You see, both these rods, they should have the same length. The diameter of the both rods should be same. So these are the 2 points you can write here. Let me show you what the answer I have written. Okay, so length of both rods is same and the diameter of both rods should be same. Okay, so the next question. Then he says, explain what happens. Explain what happens and state how she determines which metal is the better conductor. Okay, so when you heat these ends, the metal in which the heat will be transferred fastest, there the wax will melt first and the pin will drop first onto the ground. So the rod from which the pin will drop first to the ground is the better conductor. So this is how you will write this answer. This question is this. So that rod is better conductor from which the drawing pin drops first. That's our answer. Okay. So let's go to the next question, next part, I mean. So we are done with the question number 1. So let me show you the marking scheme. So the marking scheme is coming up onto your screen. Okay. So the marking scheme of the question number 1 is showing up on your screen. Pause this video and take your time. Read the marking scheme carefully for the question number 1. The answers with your answer. It's very important to check each and every question you solve with the marking scheme. Okay, so here we go. A student has two identical springs. He suspends them from a thin metal bar that is held in a horizontal position between two stands. He hangs a load from one of the springs as shown in the figure 2.1. This spring extends by a distance h. So both these springs were identical, but with this right spring, they have hung some load. So now its length has increased. So the difference between their lengths is h. So whatever is the difference between. So on figure 2.1, show clearly the distance h. Okay. So from here, the point from here to this point. So this length will be h. Let me show you. I've drawn that diagram. So you can see where this hook is attached. From this point, you take the same point on both the springs. So from this hook to this hook. So that h is actually showing you the extension. Okay. Then the question is, describe a practical method that the student can use to ensure that he measures the distance h accurately. Okay, so if you want to measure this distance, so the method can be that use a scale, a ruler, and a set square. Check what's the height of this point from the bench, and check what's the height of this point from the bench. And then from this h, subtract from this height, subtract this height. You will get the h. You can use set squares. By placing the set squares here, you will make sure that the scales are vertical. And by using the set squares here, you will be able to measure this point's height accurately on the scale. So let me show you my work. Measure height of bottom of the left spring from bench. Measure height of bottom of right spring from bench. Difference of heights is h. Height is measured with the rule and use set squares to make sure that the rule is vertical. So that was the question number 2. A and second part, which was a 1-mark question. Then the student removes the load and then inserts a small wooden rod of negligible mass into the rings at the end of each of the 2 springs. He suspends the load from the middle of the rod as shown in the figure 2.2. He checks the wooden rod is horizontal and then measures the extension h of one of the springs. Explain why it is important for the wooden rod to be horizontal. If this rod will be horizontal, then the load on each spring will be uniform. They both will have the same load if this rod is horizontal. If this rod will be horizontal, both the springs will have even, or you can say same extension. Let me show you my answer, my written answer. When rod is horizontal, load will be evenly distributed on both springs and both rods will have same extension. Here I wrote rods. This word is not rod. This word is both. Let me write here this word. This word is both springs. Okay. Both the springs will have same, okay, same extension. Okay, so now the next question is, suggest how the student check that the rod is horizontal. The method is very simple. You see the rod, this is the left end of the rod, this is the right end of the rod. You check the height of the left end of the rod from the bench. Check the height of the right end of the rod from the bench. If both these heights from the bench, they are equal, that will show that the rod is horizontal. Another method can be that place a spirit level here. If the spirit level will be, or you can place it here, or you can place it here. If the spirit level will be, the bubble of the spirit level will be in the center, that will show that the rod is horizontal. So it's a 1 mark question. Check the height of the left and right end of the rod from bench. If heights are same, the rod will be horizontal. Okay. The experiment is repeated using more identical springs until there are 8 springs hanging side by side. So basically here you have 2 springs hanging vertical parallel to each other. Then he hung here 3 springs, 4 springs, 5 springs, 4 springs, 3 springs, 4 springs. Like the springs are parallel to each other and a rod is used and the load is hung. The experiment is repeated using more identical springs until there are 8 springs hanging side by side. The extension H is measured each time a spring is added. The results are shown in the table figure 2.3. So when there is 1 spring, the extension is 19.8. When there are 2 springs, the extension is 9.8. When 3 springs, the extension is 6.5. 4 springs, 4.9. 5 springs, 4. 6 springs, 3.6. 7 springs, 2.8. And 8 springs, then 2.5. They say, on the figure 2.4, plot a graph of each centimeter on the y-axis against n on the x-axis. So the extension is on the y-axis and the number of springs hanging parallel to each other, that is on the x-axis. Start your axis from the 0, 0, draw a smooth curve of the best fit. So this is that graph which we have to plot. It's a 4 mark question. And let me show you. So it's a 4 mark question. So first of all, you can see that I have labeled the x-axis. X-axis here, the n number of springs, 1, 2, 3, 4, 5, 6, 7, 8. On the y-axis, h, which is extension, and this goes up to 20 centimeter. So here's the extension, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So this is how you label the grid, the graph. Okay. Now you can see I have plotted when there was 1 spring, the extension was 19.9. When 2 springs, 9 point something. Sorry, this is 19 point. This is 9 point. When 3 spring, when 4 springs, when 5 springs, when 6 springs, when 7 springs, when 8 springs. Okay. So this is how you plot the points. Now you can see here, I have joined them with the smooth curve. This is the curve of best fit. Now their question is, let's see, what's their question? We have drawn the diagram. So describe the relationship N and H. So let me show you. Okay, so you see, as the N is increasing, the H value is decreasing. Okay. When the there's 1 spring, the value is approximately 20. And when you made the N2, the value becomes 10. So when you double the number of springs, the extension become half. Now from 2, if you make the springs 4, the extension from 10 becomes 5. So it means that when you are increasing the number of springs, the h is decreasing. If you double the number of springs, the h becomes half. So I can say that h and n, they are inversely proportional to each other. So when n is doubled, h becomes half. So n and h are inversely proportional to each other. Okay, so let's check what's the next question. Okay, the student now hangs one spring from the end of a second spring and suspends them as before. He hangs the same load from the end of the spring combination as shown in the figure 2.5. Their question is, suggest a value for the total extension of the pair of springs in the figure 2.5. So this load, when it is hung with a single spring, it produces, I think, 19.9 centimeter extension. These springs, they are attached with each other like in this manner. So both the springs will have the same extension. This will be have a 19.9 extension. This will also have 19.9 extension because that load is fully on each. So you can see that the load on the extension produced in each spring will be 19.8 and 19.8 because the load is full load is on one spring. The other second spring is also experiencing the same full load. So they will have 19.8 extension in one spring and 19.8 extension in the other spring. So the total extension will be 39.6, which is approximately 40 centimeter. So here the 19.9 or 19.8 extension will be produced in this. Same extension will be produced in this. So the total extension will be approximately 40. This is what this is all about. Okay, so now let's move to the next part. Okay, so we are done with the question number 2. So let me show you the marking scheme. Okay, so the marking scheme of the question number 2 is showing up on your screen. So pause the video, take your time with this marking scheme. Let me show you the, okay. So you can take time, you can pause the video and read this marking scheme very carefully. This is the 2A part, B part, and this is the 2C part. Okay, now a student has 50 small glass beads of different sizes and shapes in a jar as shown in the figure 3.1. One of the glass beads is spherical. Suggest a piece of apparatus that measures the diameter of this bead more accurately than a ruler. So you can use a micrometer here. You can also use a vernier caliper. Micrometer will be more accurate. So write micrometer. Micrometer is the answer. Okay. This bead is drawn to full size in the figure 3.2. Use a ruler to measure the diameter of the glass bead in the figure 3.2. You see, here, from here to here, whatever is the maximum distance possible, with the help of the rule, measure this. It will be approximately 3.4 centimeter. But when you will measure from your paper, because your papers are photocopied, the length will be little less than 3.4 centimeters. So it's all right. Okay. So I have not written this answer here. That's 3.4. Okay. The answer is 3.4. Okay. Of the previous question. A second part and its first portion, the answer is 3.4 centimeter. This diameter is 3.4 centimeter. Okay. Their question is, so here write 3.4 centimeter. 3.4 centimeter. Explain how you measured the diameter as accurately as possible. You may draw on the diagram if you wish. So it's a 1 mark question. So I will place a set square here, and I will place a set square here, and I will place a scale here, and very easily I will find the diameter. Let me show you my answer. Okay. So you can see I have placed a set square here, a set square here, and I have placed a ruler here. And with the help of the rule, I can measure what is the diameter. Place set squares around the bead as shown in the figure 3.2. Use a rule to measure distance between the set squares, and that will be the diameter. Very simple. Okay. Now, the next part is question number 3, and it's B part. The student finds the average density of the glass of the glass beads in the jar in the figure 3.1. Describe a method to find the total volume of 50 glass beads. State the apparatus used and explain how it is used. You may draw a diagram if you wish. Okay, so it's a 3-mark question. Let me show you the whole question. Okay, so hopefully it is visible on your screen. It's a 3-mark question. So I will take a measuring cylinder, I will fill it with water, I will note down what's the volume of the water. I will call this volume V1. Then I will put 50 glass beads into the water, and I will check the volume of the water now. I will call it V2. V2 minus V1 will be the volume of the 50 glass beads. So pour water in the measuring cylinder, note the volume of the water, V1, put 50 beads into water, note the volume of the water with 50 beads in the measuring cylinder. We will call it V2. Volume of the beads will be V2 minus V1. Simple. State a precaution taken to ensure an accurate value for the volume. You see, the beaker should be large enough to hold water and the 50 beads. All the 50 beads should be submerged in the water. They should be under the water. And then you will get the accurate values. Okay. All the beads should be submerged in water. Cylinder should be large enough to hold water and 50 beads. Now, the total volume of beads is 196 centimeter cube, and the total mass is 523 gram. Use the equation density is equals to mass divided by volume to determine the average density of the glass of the beads. Give your answer to the 3 significant figures. Okay, so here you have 190, the mass is 523 gram. The volume is 196 centimeter cube. Just divide them on the calculator, you will get the answer. Let me show you my answer. So 523 divided by 196, it will be 2.67 grams per centimeter cube. 2.67 grams per centimeter cube. A very simple and straightforward question. Okay. So now on your screen, the question number 3, its answers are showing from the marking scheme. Pause the video, take your time, read these answers carefully, check for each mark that what can win a mark for you. So it's very important to read the marking scheme. Always check your answers with the marking scheme. A student measures the refractive index N of a rectangular glass block. One face of the block is shown in the figure 4.1. A student, so it's a glass block, a student traces the path of a ray of light entering the block at the side AB. So from here, a light is entering into the glass. And leaving from here, the light is emergent, it's coming out from this glass block. And leaving the block at the side CD suggests the apparatus needed to carry out the task. If you want to do this experiment, you need a paper on which you will place this glass block. You need a ray box for the light ray, and you need a pencil to put marks on the incident ray and on the emergent ray. So you have to write the names of that apparatus. Okay. Ray box, paper, pencil, and ruler. So if you place the ray box here, for example, this is the incident ray, and here it is touching the AB side. This is the emergent ray, and the light ray which is coming out of the glass block from the CD face. And if you place this glass block on the paper and you may mark its boundary, and then you use this ray box for the light, automatically this incident ray will be visible, this emergent ray will be visible. On the paper, put 2 crosses on the incident ray, put 2 crosses on the emergent ray, then remove everything, then join these points, these crosses until you reach the CD. Join these 2 crosses until you reach the side AB. So join this point of incidence and this point of emergence. Remove all the glass blocks. Then join this point, emergent point, and the incident point with each other. So this line which you have drawn actually is the path of the light inside the glass block. And this is how you can trace it. So that's the question. Next question. Okay. It says, explain in detail how the student traces the ray of light through the block. You may add to the diagram in the figure 4.1 if you wish. So I have shown you the figure. This is that figure which you have to draw. Okay. Place glass block on paper. Mark the boundary of block on paper, glass block on paper. Direct ray box towards the face AB. Put crosses on the incident ray and on emergent ray. Remove the glass block and join crosses on the incident ray to AB and emergent ray to CD. Then join the point of incidence on AB with the point of emergence on CD. This line is the path of light in the glass block. It's a 3-mark question. Hopefully you understand. Okay, so then the next part. Here we go. Figure 4.2 shows the ray that the student traces through the block. Measure the angle, he says, measure the angle of incidence I and the angle of refraction R at the point where the light enters the glass. Okay. So here the light is entering the glass. So here I have to measure the angle of incidence and angle of refraction. I will draw a normal here. I will, with the help of a protector, I will check how much is the angle of incidence and how much is the angle of refraction. Let me show you. So this blue color line, you can see this is the normal. So place the protector like this. So this angle between the normal and the incident ray, that is the angle of incidence, and it's like 50 degree. This is how you will place your protector. This is on the normal, and this is the refracted ray inside the glass block. So the angle between them is like 30 something. Okay. So the angle of incidence is 50 and the angle of refraction is 30 degree. Okay. So this is 2-mark question. Question number 4, and it's D part. It's a 2-mark question. The refractive index N of the glass is given by the equation N is equals to sine I by sine R. The student repeats the experiment using rays with different values of the I, means the angle of incidence is different. In the space below, draw suitable results table that the student uses to record all the data needed to find N. In your table, show the values for I and the student should choose, that the student should choose. Okay, so let me show you. So here you can see that I have drawn a table, angle of incidence, that will be I, angle of refraction, that will be R, sine I, sine R, and then the N, that will be sine I by sine R. So the angle of incidence can be like 10 degree, 20 degree, 30 degree, and 40 degree. So that's the last part. So we are done with this question, with this paper. So let me show you the marking scheme. Okay. So the marking scheme for the question number 4 of this paper is showing up on your screen. Pause the video for some time and read the marking scheme. Check my answers and your answers with compare them with the marking scheme. It's very, very important to check yourself, your answers, your written answers. You should compare them with the marking scheme. Okay, so my dear students, today we have done May, June 2018 and 4-1 paper. We have done an alternative to practical paper. I've tried my best to explain to you and I have tried to explain the concepts of this paper, and I've tried to make this paper easier for you. So if you are watching this video and you find this video helpful in preparing your alternative to practical paper 4 ATP paper, share the link of this video in your Facebook account, into your Instagram account, or into your Twitter account. This will help me promote my channel, and that is a great appreciation for me. So thank you very much, everybody. It's a pleasure for me to teach you all online. I hope that I am to some help to you. Thank you very much once again. Have a good day. God bless you all.